low asymptote because the curve is not, or the function is not infinity at any infinite value. As x increases, the y is not increasing. Now, this point, beyond this point, the curve is not lying, will not exist. So this kind of question is solved in this way. So low asymptotes are there, but figure is of this kind. Okay, this is casing of this question number 10th here. Now let me take 11th question. What does 11th question say? Question number 11. Let me talk about it. Here, question number 11 states the curve. Okay, this is x upon a whole power 2 by 3 plus y whole power 2 by 3. 11th question, x upon a, this is y upon b whole power 2 by 3 is equal to 1. It's known as hyperbolic hypercycloid. Okay, this is a shape of hypercycloid. Hypercycloid. Okay, this question. Now, if I write this just symmetric, yeah, let me find out, is it symmetric to both the axes? Because x and y both are even number here. If I write it as x upon a whole power x square a square into 1.3 whole power plus if it is y square upon b square whole power 1.3, then this equation is symmetric to both the axes. This even term here. The curve is symmetric. So the first point, the curve is symmetric to both the axes. Curve is symmetric. The curve is symmetric about both the axes. About both the axes. Symmetric about both the axes. So if I put y equal to 0 here, then what is the value of x? Okay, because it is symmetric about both the axes, then this equal to this x will be equal to a upon 1.3, or if I solve this equation, it will be 1 minus x square upon a square whole 1.3 is equal to 1 minus y square upon b square whole 1.3. This is the value. If I replace, put x equal to a, okay, or this is x equal to, this is 1 here, 1 will cancel out, y equal to b, y equal to plus minus b. Or if I put y equal to 0, let me take, putting y equal to 0, y equal to 0, sorry, putting y equal to 0, we get this x square upon a square whole power 1 upon 3 is equal to 1, so this is 0. Okay, so x equal to, x square equal to a square or x equal to plus minus b. Similarly, y equal to plus minus b. So y is 0 and x is plus minus a. That means points are a0 minus a0. The 2 points lying on the curve will intersect the x-axis at these points. Okay, there's a point. Similarly, y, for y also, if I put x equal to 0, y will be b plus minus b, same question. So what are the points then on y-axis? It will be 0 and plus b and 0 and minus b. The curve is intersect. This is elliptical type of curve here. So in this type of curve, the curve will be of this kind. The points on the axis, this point is minus a0, sorry, plus a0, So this is minus a0, and here it is suppose b 0 and plus b, and this is 0 and minus b, 0 and minus b. So we can say like this. Okay, so this is the x-axis, x-axis, origin, y-axis, y-axis. These 4 points are there lying on the axis of x. These 4 points are there, and on y-axis, the curve is intersecting the y-axis at these 2 points. If I join them, so this kind of shape will be obtained. This is what we have obtained the shape of the question number 10 or 11. Sorry, question number 11 is having the shape of this kind. Curve is traced in this way. Okay, this is question number 10 here. Now, y equal to plus 1 c plus 1 b, we have solved this equation. So this is no asymptotes here because the curve is not meeting at intercepts. No asymptotes. No asymptotes here. Okay. This is shape of the question number 11. We have done. Now, 10th question, for the 12th question. Let me see what kind of shape is there. So here no asymptotes, because of that we have taken these points. So it was symmetric to both the axes. Question 11 was symmetric to both the axes. We have seen that what kind of curve was there. Now 12th question. 12th question again is similar type of question. Okay. This is x is equal to 2 by 3. Okay. And plus y raised over 2 by 3 equal to a raised over 2 by 3. Okay, solution. If I divide this whole equation, can be written as 2 by 3 divided by a raised over 2 by 3 plus y raised over 2 by 3 on a raised over 2 by 3 equal to 1. Or can be written as x square. It can be written as x square upon a square whole power 1 upon 3 same. Y square upon a square is a square here, 1 upon 3 equal to 1. So this is, we see that the curve is symmetric to both the axes. From this, because even term x is also even term, y is also even term. So the curve will be symmetric will be symmetric. Sorry. This is will be symmetric about both the axes. About both the axes. This we have seen. If I put x y equal to 0, but in both the axes it is symmetric. On axis of x, if I take y equal to 0, if I put, so y equal to 0, putting y equal to 0. So it is passing through, it is not passing through the origin. The curve is, you can say this also, the curve is not passing through origin. So this is constant term, independent constant term. Curve is not passing through origin, not passing through the origin. Okay, then here y equal to 0, if I substitute in this equation, we will get x square upon a square whole over 1 upon 3 equal to 1. So x square equal to a square, or inside that x equal to plus minus a. At y equal to 0, we get the point a0 and 0 minus a0. So the x-axis, okay, the curve will intersect the x-axis at these points, these 2 points, a0 minus 0. Similarly, if I put x equal to 0, if x equal to 0, then that will also be the same kind, 0 and a, and 0 and minus a. So the y-axis will be intersected by the curve at these 2 points. So what is the shape of the curve? The shape of the curve will be, that will, well, this is elliptical type of question, but the shape of the curve will be of the same as we described in 11th question. Shape is This is the point here. This is the point. This is the point. Shade height here. This is A0. This is minus A0. This is 0 minus A. This is 0 plus A. So we can say like this. This is there. This is sorry. This is there. This is there. So these 4 points are here on the two axes, x-axis, origin, x-axis, y and y-axis. So these are the 2 points on the axis of x, A0 minus A0. That will be the curve is intersecting. The curve is intersecting. So these kind of, we can say this is the double point here, and this is the first species of cusp type. Okay, this is a double cusp here. This cusp and this cusp, this cusp. Okay, number of cusps are there. So this is, I think, elliptical formula, but this is 1.3 power. So because of that, the shape is of this kind. Okay, so this is 12th question. The shape of the 12th question we have done. Got 12th we have done. Now, 13th question, let us discuss about. Okay, let's discuss about question number 13th and 14th. This shape of the 12th question we have done here. Okay, now in this case, no asymptotes, because asymptotes is not there. There is no infinite tangents here. Tangents is not meeting the axis at the infinite. It is meeting and not meeting. So no asymptotes here. The 12th question, 11th question, no asymptotes. No. 10th also there was no asymptotes. In 9th also there was no asymptotes. Now 13th question, let me discuss. Here the curve is x square y square is equal to a square into y square minus x square. Okay, so if I equate the like terms of this equation to 0, y square minus x square equals 0. Solution. Now again, the curve will be symmetric to both the axes. First point, the curve will be symmetric, or is symmetric about both the axes. About both the axes. First point. Second point, it is not passing, it is passing through the origin. It is passing through the origin. It is passing through the origin. Second point. Okay. Now, third point. If I put y equal to 0, 0, so s will also be 0. It means origin is there. No. Now, equating smallest degree term of this equation, this is first equation with 0. Equating smallest degree term. Degree terms to 0, we will get this equal to 0. If y square minus x square equal to 0, or y equal to plus minus x. So I mean these two x's are there, y equal to plus x and y equal to minus x. It means this is plus x, y equal to minus x. Now, here the two lines, okay, about which the curve is symmetric. For the two tangent lines, we can say the smallest degree term we have equated. So these are two tangent lines which are the straight lines passing through the origin. Okay, that we know about. Now, fourth question: what are the points which are lying on this curve? Okay, because y equal to x, if I substitute in this whole equation, we will get 0, x is 0. So the point on, if I put y equal to x, this is 0, y equal to x square minus x square is 0. This is x4, then x4 equal to 0, so x equal to 0. So between 0, 0 is the point which is passing through the origin. Okay. Now again, if I shift to the another point, but point is not found, only 0, 0 is the origin at which the curve is meeting. Curve is meeting at this point. This curve is symmetric with the. Now, if I put x equal to a and minus a here, okay, if I equate the y value of y, if I find out, then the value here y minus x square and y. Okay, so that is the point. If I solve this equation, solving this equation, x square into y square, okay, equal to a square into y square minus a square into x square. Y square, if I take common, a square. If I take y square common, it will give us x square minus a square equal to minus a square into x square. That means y square is equal to minus a square into x square divided by x square minus a square. Okay, so these are the 2 points here, x equal to plus minus a, at x equal to a, or if x square is, this value is negative always, but x positive if I take the denominator when x tend to a, or x equal to a, x equal to plus a and minus a, y will be infinity. Okay, that means it cannot be equal to a. If x is lesser than minus a, it will be negative sign. Minus sign here, it will be x positive. On this side, it will be negative, then y is not existing in that situation. Okay, so that means x equal to, from this equation, x square minus a square, coefficient of y square equal to 0. If I equate coefficient of y square equal to 0, x equal to plus minus a. X equal to plus minus a. It means these are the 2 lines. Or if I put x equal to a plus minus a, this is x square minus a square. Okay, x square minus a square, not positive. If I take this to this side, okay, x square can be then calculated. So if I find x square equal to, that is the positive side. So x square, if I also find out from this equation, that will give us x square positive side. Okay, so y square, then taking common, that we have taken common, x square if I take common, then y square minus a square. It will be y square minus a square equal to a square positive. So x square will be a square by square upon y square plus a square. This is another point here. That means y square plus a square. In this case, y, if it's minus 1 equal to or greater than value, positive value, y is positive in this way, actually positive always. That means, but this equation x equal to plus and y equal to minus a, these are the 2 tangent lines we have taken. The 2 tangent coefficient of y square we have equated to 0. So that means small h degree term here. So that means the curve will be of this kind. Let me draw the curve here. From the curve it will be obvious. So in this case, the 2 lines x equal to minus a, this is x equal to minus a, and this is, because x cannot be equal to minus a or plus a, at that point y will be infinity, y will not be, because that is not tend to 0. If it is negative value, y square is negative, or in the denominator, then, or sorry, by x square is negative, the minus sign, so it will be negative, it will be positive side for it. Minus sign is there, x equal to a plus a. So what is the curve here? Well, when x tend to, when x tend to negative value minus a, y tends to infinity, as we have seen. Why? Because y square was equal to minus a square x square divided by x square plus minus a square, minus a square. This is the value from this. Y is infinity when x tends to minus a. X square is numerically equal to, suppose minus, beyond this minus a or equal to minus a, so it will be a square minus a square 0. if I just take this value a, x equal to at minus a also, at x plus a, the curve will be negative. And if I take x equal to positive a here, it will be again a square minus a square 0. It will be negative value. Y will be negative in the situation. So this is the asymptotes here. X equal to minus a and x equal to plus a. Okay, similarly, it is plus minus sign here. When x tend to negative value, so y is coming out plus minus here. Y is equal to plus minus sign with negative sign. This value y is equal to plus minus sign. So y will be at minus a, it will be plus infinity and minus infinity as well. Plus infinity and minus infinity. And x will be minus a, but it tends to minus a. X tends to minus a, then minus a is a negative positive value, but it is, if it is even minus a, x equal to minus a, is a square minus a square is 0. It is 0, something upon 0 is negative. I mean infinity. This y will be plus minus infinity. The value comes out to be. It means plus infinity and minus infinity. This is the curve here. Second curve. This is also going to the side. This type of shape will be of the curve. This is y-axis, y-dash, y-axis, this is x-axis, x-axis. So within these two lines, x equal to a and x equal to minus a, the curve is defined here. Okay, so when x tends to plus a, y tends to plus minus infinity. 0 in the denominator, plus minus infinity here. That we have taken plus minus infinity and plus infinity at x equal to a, and x equal to minus a, y is again minus infinity or plus infinity. So this is the same type of figure. This is the shape of the question number 13. Because we have seen here that this origin is there. This is origin 0, 0. It is passing to the origin only. Okay, so at the origin, it is working as a double point here. Okay, so this kind of shape of the curve is there. Question number 13. Question 13 we have done here. Now let me take the 14th question, the last one. Now in question number 14, let me do that in detail, one by one step, so that one can understand what is the logic behind every question here. Okay, so let me take question number 14, the last one. What is it say? It says trace the curve. 14th question. Now trace the curve. The curve, what is the curve here? It is y square into x minus a, okay, is equal to x square into x plus a. Okay. So first, if I solve this equation, y square will be this equation for solution. Find out. So here we see here y is even power, so it is symmetric to x-axis. So it is symmetric about x-axis. Curve is symmetric about x-axis. X-axis. What is the reason? Because y is even power, symmetric to y about x-axis. And then second point, it is passing through the origin. It will pass through the origin. It will pass through the origin. The origin will lie upon this circle, so it will pass through the origin. It is the second point. Third point, when I put y equal to 0, then if putting y equal to 0, y equal to 0, what do we get here? We get this point x square into x plus a equal to 0, so x equal to 0 and x equal to minus a. What are the points here? 0, 0, and minus a and 0. Okay, so there are 2 points here. That minus a 0, if I shift the origin to this point, shifting the origin, curve, is meeting the x-axis at these 2 points. So shifting the origin to the point minus a0, to the point minus a0. So from equation number 1, from equation number 1, we get, so replacing y by y, no problem. But x, in place of x, we have to put x minus a. Which is x minus a is already there. It is equal to x square, that means x minus a whole square. In the bracket it will be x minus a plus a, that means f only. Second equation. Now in this case, the smallest degree term is from this. It is y square into x minus twice a equal to x square minus plus a square minus twice ax into x. Here x into a square is the smallest degree term. So x equal to 0 is the line at between. Okay, x equal to 0, that means y-axis is the new tangent line. Let me write here. So x equal to 0, equating the smallest degree term. Let me write here. Equating the smallest degree term. Equating the smallest degree term. 0. This is x equal to 0. Why? Because this a square into x equal to 0. That means x equal to 0. X equal to 0 or the new y-axis. The new y-axis will be a tangent to the point, or at the point, tangent at the point minus a0. Is it minus a0 or minus b0? Minus a0. Tangent at the minus a0 it is. Now if I just solve this equation and then let me solve the given equation then. Minus a0 and minus a0 is one of the points, and let me solve it. It is y square into x minus y square a is equal to x square into, that means x cube into x square a x cube plus a into x square. If I equate this by square x square that side, equating smallest degree term here again, equating the smallest degree terms here also, that will give us a x square plus a y square equal to 0, or x square equal to minus y square. So it means y equal to negative value, which is not possible. The curve will be here. It is positive, negative here. There is a minus sign here, this plus sign. So these two, sum of these two will be equal to 0. These are two smallest terms here. So x equal to minus y, that means y equal to y square equal to minus x square. That means y is imaginary here. Whatever value of x we substitute, y is imaginary here. That means the curve will not exist between these 2 points. So what are those points beyond minus a or plus a? If I substitute x equal to minus a here, we again negative. But at the point x equal to minus a and 0, the curve will not be. Okay, so x equal to minus a and plus a. Minus a and 0 and plus a and 0. Let me take that. What is the situation here? So putting y equal to 0, we obtained x equal to 0 and this, and equating coefficient of y square equal to 0. second equation equating coefficient of y square 0, coefficient of y square to 0, but we get x minus a equal to 0 or x equal to a. X equal to a is also the point. Okay, after that or between these 2 points here, because if I find y square equal to x square into x plus a upon x minus a. Okay, from this if I see that between the points a negative value and plus a, minus a to plus a, there is no curve. Curve will not exist between x is greater than minus a, less than a. That means at x equal to minus a and x equal to plus a, beyond that, or sorry, between this range, the curve will not lie, because in this situation, if I put negative value here, the curve will be negative at x equal to, or if x is less than minus a, sorry, greater than minus a, here greater than minus a, it is x is greater than minus a, greater than minus a, the curve will be negative, so y square will be negative, here. It means curve will not exist between, so the curve will not exist in this range, in the range minus a to plus a. Okay. Minus a greater than, less than, x is less than a. X is greater than minus a and less than a or equal to a here. Beyond that, the curve will lie. Curve is not existing between this range. What kind of figure will be there? Shape of the curve in this case should be that we take. Now in this case, suppose this is a, x equal to a. Here it is minus a, x equal to minus a. Here it is x equal to plus a. Okay, so when x increases, x is going to, or x decreases, when x decreases, the y will be negative value. So the curve, then y will be minus value is x square minus a in this case. That will be greater value because minus a whole square is positive value.